Okay, so if we're taking a look at bone development is also referred to as, where's my pen? Ossification. You can also call it osteogenesis. So there's different types of ossification or different times in a human's life that you're going to have bone growth or bone development. First of all, you have embryonic bone development, and that's when you're at the stage of an embryo, and the bony skeleton is not yet formed. So basically what's going to happen is you're going to go from pre-bone, so fibrous connective tissue membranes or hyaline cartilage are going to be converted into a bony skeleton. So that's the first time that you're going to have, or the first type of example of bone development. You're also going to have bone development from childhood to early adulthood, so to the end of puberty. And that's when the bones are going to grow in length and size. After puberty ends, then you really don't have bone growth in the sense that your bone's getting longer. You don't get any taller after puberty. So in an adult skeleton, you're only going to have bone development in two forms. You're going to have repair, and that's if you break a bone, then obviously you're going to have some bone growth or bone development to repair the broken bone. And then also what we call bone remodeling. And we'll take a look at what's involved in bone remodeling in a little bit. So we're going to talk about the formation of the bony skeleton. So the formation of the bony skeleton begins around 8 weeks in utero. And basically, before the skeleton is made up of bone, it's made up of two structures. It's either going to be made up of, fibrous connective tissue membrane, or it's going to be made up of hyaline cartilage. And basically, during this process that begins around 8 weeks in utero, you're going to be converting the fibrous connective tissue membrane into bone, or you're going to be converting the hyaline cartilage into bone. So, which process is used? There's basically two types of bony skeleton formation. You have intramembranous, or you have endochondral. So the name tells you where it's coming from. So for example, intramembranous, within a membrane, all bones that are made up of fibrous connective tissue before they're converted into a bone are going to use intramembranous ossification. All the structures that are made up of hyaline cartilage are going to use endochondral. So endochondral means within cartilage. And then that makes sense that it would be hyaline cartilage. So different types of bones use different types of, or use these different mechanisms. So we're going to take a look first at intramembranous ossification. And intramembranous ossification, as you remember, is going to be how fibrous connective tissue membranes in the embryo gets converted into bone around 8 weeks. And the bones that use intramembranous ossification are all the flat bones. So you think about where you have flat bones, the bones of the skull, the scapula, the sternum, the pelvis, etc. So they're going to use intramembranous ossification. Okay, so remember, we're going to take a fibrous connective tissue membrane and we're going to convert it into bone. So you don't have to know all these steps. I'm just going to highlight a few things about the different steps of this process, but you don't have to memorize every single step. I'll tell you at the end what you do have to know. Okay, so intramembranous ossification is going to begin in this fibrous connective tissue membrane. This fibrous connective tissue membrane is made up of what we call mesenchymal cells, and those are just a type of stem cell that when they receive a signal, they're going to differentiate into other types of cells. Okay, so the mesenchymal cells are going to differentiate into what we call an osteoblast, and that's just an immature bone cell. So you've heard of osteocyte. That's a mature cell. Now we're going to talk about an osteoblast, which is an immature bone cell. And also, when you hear the term blast, think of building. So osteoblasts build bone. And then there's a third type that we'll talk about in a little bit called an osteoclast. And those are bone-destroying cells. Okay, so let's go back to this. So the mesenchymal cell is going to receive a signal, and they're going to start differentiating into osteoblasts. So here's all your different osteoblasts. They form what we call an ossification center in the middle of this fibrous connective tissue membrane. Okay, so these osteoblasts form this ossification center. Now, the next thing that happens is that these osteoblasts are going to start secreting a matrix. So that's what osteoid is. It's just another name for the matrix. So the osteoblasts start secreting this matrix all around them, and then within a few days, that matrix calcifies and becomes hardened. So this should look familiar to you. Here's your osteocyte, and it's kind of trapped in this little cavity because the matrix calcified. Remember, that's called the lacuna. Okay, so you're going to continue to have this bone develop as more and more mesenchymal cells become osteoblasts, and then they secrete a matrix, and they kind of surround themselves with this osteoid, and then the osteoid calcifies in a couple days. This is basically, I don't really care about this slide too much. This is basically telling you that you're going to have embryonic blood vessels are going to kind of grow in or move in where you have the trabeculae or the spongy bone. I don't really care about that one. You don't have to know anything about that. So this is kind of showing you where the compact bone forms on the outside of the spongy bone. So what you want to think about is, okay, so it's called lamellar bone, and that's just another name for that compact bone on the outside. So this lamellar bone replaces the woven bone or the spongy bone on the outside. You have periosteum out here, and then you have this collar of compact bone. And you have the spongy bone that's found in the middle that's going to have the red bone marrow. So if you think about that, that makes sense because this is what you're used to seeing when you think about a flat bone. So if a flat bone, one of the characteristics is that it's going to have a layer of compact bone, a layer of compact bone, and then what do you have in between? Spongy bone. Okay, so this layer of compact bone is here. And this layer of compact bone is here. So you have this hard calcified column of compact bone on both sides of the spongy bone. So that's intramembranous ossification. Next we have endochondral ossification. So within cartilage, the type of cartilage that we're replacing is going to be hyaline cartilage. So all bones from the base of the skull, this excluding clavicles and flat bones, are formed by this method. And this begins around the second month in utero. So you're going to be taking the hyaline cartilage and you're going to be breaking down the hyaline cartilage and forming bone. So what's important to know about this? So this is kind of showing you a long bone. It's made up of hyaline cartilage. So see how it resembles the same shape of a long bone, but it's just a hyaline cartilage instead of bone. So what you're going to have happening is that you're going to have a bone collar is going to form around the diaphysis of the hyaline cartilage model. And then you're going to have what we call a primary ossification center beginning in the middle of the diaphysis. And then basically what's going to happen is you're making the medullary cavity, and then you're going to have blood vessels coming in, growing into it. And then you have a secondary ossification center that begins in the epiphysis. So in the proximal epiphysis and the distal epiphysis. And you're going to have that's called the secondary ossification center. So you're going to have the epiphysis is finally going to calcify, and you're going to have this compact bone with the spongy bone in the middle. You're going to have a layer of hyaline cartilage left on the outside, and we already talked about that. That's the articular cartilage. But you're also going to have these epiphyseal plates. Okay, so these are plates of hyaline cartilage. So that didn't turn into bone. You just have an area, which is the growth area, active growth area, called the epiphyseal plate, that allows this bone to elongate as the baby grows. So this is going to constantly, until adolescence, the hyaline cartilage cells are going to further differentiate into bone cells, and they keep expanding the length of the bone. And then when you have the onset of puberty, then these epiphyseal plates calcify, and they become the epiphyseal line. So that's how you can tell if a bone is of a young child or an adult, is if this is calcified or if it's active tissue. So, excuse me. That is basically what you need to know about the two processes. So you want to be able to, for the testing purposes, is you want to be able to compare and contrast the intramembranous ossification and the endochondral. Okay, so you want to be able to tell how are they the same and how are they different.